Pascal law says that pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluid is equal in all direction. So remember, this Pascal law is very important, and we have very much too many practical applications here. That Pascal law says that the pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluid is equal in all directions. The hydraulic machines are based on the Pascal law. Hydraulic machine mean the liquid based machine. Basically, if somebody is asking you that what is a hydraulic machine, hydraulic machines are the liquid based machines. So I'm going to tell you that how the hydraulic press or hydraulic jack are working. We have to discuss the working principle first of all. Working principle: liquids are virtually incompressible. First of all, you must remember, you know that the liquid molecules are very much close to each other, so there are negligible intermolecular spaces. So that is why the liquids are incompressible. If the pressure is applied to any point to the surface of the liquid, that pressure is transmitted throughout the liquid. This is the Pascal law. Okay. Now for the explanation, as the input force is applied on the small piston, now we are going to discuss that what is this. You can read this explanation from the notes. Okay, in the comments this explanation may be given. So here we are going to discuss this now. Well, now let us consider a piston. One is the larger piston and other is the smaller piston. Here you can see the diagram. This is a larger piston of area A1, and you can say that the larger piston has the area A1 and the smaller piston has the area A2, we can say. So the smaller piston, force is applied, F1 force is applied on the smaller piston, then how much weight we can lift from the larger piston. Now let us see. Here you can see that I'm drawing two pistons. For example, this is a smaller piston. A force F1 is applied on this piston. Okay. Now the area of the smaller piston, say it is A1, and this is a larger piston. We have to lift a weight from this, say weight is the W. Now, how much weight we can lift with this, with the help of this smaller piston by applying F1 force? You will have to observe it very carefully. And this area, say the area, this area, say this area A2 is the area of the larger piston. Now, as you know that pressure, the formula of the pressure is equal to force over area. Now the pressure on this left piston is, say it is P1 F1 over A1. Okay, this is the pressure on this piston. Now the pressure on this piston, say this is P2, pressure on this piston is equal to W, weight. Weight is also a force, you know that, over A2. Now, as we have discussed the rule, the mechanism which we are going to apply here is this, that if the pressure is applied to any point on the surface of the liquid, that pressure is transmitted throughout the liquid. It means whatever the pressure is being applied from this piston, so that pressure will be transmitted throughout the liquid. So whatever the pressure is generated here, the same pressure will be on the walls of this container also. Very carefully look at this, that the same pressure will be on the walls or pipes, etc. That pressure will be the same on all sides of the container, and the same pressure will be on this piston also. Okay, whatever the pressure is generated due to the force F1, that pressure will be transmitted throughout the liquid on the walls of the container and on this piston also. It means both the pressures are equal. which says that P1 is equal to P2. Both the pressures are equal. If both the pressures are equal, then F1 over A1 is equal to W over A2. Now, this is the formula to find out that how much force you can apply to find out a certain weight, or how much weight can be lifted with the help of certain force. Now let us do some calculations with the help of this formula. Suppose this is a larger piston. Suppose the value of area is 1 meter square. Okay, here I'm taking the area 1 meter square. Now here in this here area, let us suppose it is uh, 5 centimeter square. Say this is the area is 5 centimeter square, the area A1. Now you are going to lift, suppose this is the weight of 2000 Newton. 20,000 Newton is the weight. You are going to lift 20,000 weight, 20,000 Newton weight. Now you are going to find out that how much force will be applied. If you are applying how much force will be applied if you are applying that force on the area of 5 centimeters square. Now let us do the calculations. You can also do the calculations. Please, you can do the calculations. Now you can see that here the area in meter square. Okay, in both the cases, remember this, whenever you are applying this formula, your area unit must be the same, and it is better that you must apply meter square. So this 5 centimeter square must be converted to meter square. So A1 is 5 centimeter square. So convert this centimeter square into meter square. So 5 over 2 times divided by 1000. So this will be 2 times divided by 100. So this will be uh, 0.0005 meter square. Now I am applying the values. F1 is required. F1 is equal to W into A1 over A2. The weight of the body is 20,000 Newton. 20,000 Newton is the weight, and A1 is 0.0005, and the area of A2, which is 1. This is 1 meter square. Now you know that I'm applying the mathematics to calculate this, and I'm not telling you. I know that. Okay, you know that how to calculate 1, 2, 3, 4. These 4 zeros are canceling these 4 zeros. Okay, so this is 5 2s are 10. The answer is 10 newtons. Those who got 10 Newton answer, they are correct. Now you know that. Now let us consider this. Actually, if there is a body of weight 20,000 Newton, it means the mass of the body was the mass of that body which we lifted with 10 Newton weight. That was basically 2000 kg body, which we are lifting with the mass of 1 kg only. 1 kg. So here you can see that we can lift the body of 2000 with the help of 1 kg weight. And 1 kg weight is almost the weight of a 1 liter cold drink like this, or 1 kg of sugar, whatever the weight of the 1 kg sugar is. So with the help of that 1 kg mass, you can lift the mass of 2000 kg if you have this difference of the area. Now, I hope that you have understood it very clearly that how we are going to use the hydraulic system. And hydraulic, in the hydraulics, we use hydraulic brake system, hydraulic jack, hydraulic press, etc. It is very important in our practical life.